Here we have a function that has radical expressions in it. So as usual, we're trying to find limits. So as usual, we're going to plug in the number and see what happens. So when we plug in the number, we get radical 2 minus 0 minus radical 2 over 2 times 0. So that's a 0 over a 0. Remember that 0 over a 0 tells us that it is possible to find the limit, except that we have to now use a different technique because substitution is not working. Now there's one technique that we'll use in this class, and that will work most likely if substitution doesn't work, and that is multiplying the numerator and denominator with the rationalizing factor of the radical expression. So a radical expression, let's say, that looks like this. Its rationalizing factor would be radical x plus radical a. When we multiply these two, we get a difference of squares. It's the square of the first minus the square of the second, so that is x minus a. So similarly here, notice that there is a minus here, so we would have the rationalizing factor as radical 2 minus x plus radical 2 divided by radical 2 minus x plus radical 2. So that is equal to limit as x approaches 0. Notice that radical x minus radical a times radical x plus radical a is equal to radical x the whole squared minus radical a the whole squared. So it's the square of the first minus the square of the second. The first expression is radical 2 minus x. The second is radical 2 divided by, we're going to leave this alone. We are hoping that the x will get cancelled because that is what is causing the 0 in the numerator and possibly the 0 in the denominator. We know it's causing the 0 in the denominator, so let's see if we can somehow cancel that off. So this is equal to limit as x approaches 0, 2 minus x minus 2. Remember, radical the whole squared. These two get cancelled. And whatever is left in there is what we have. Divided by 2x times radical 2 minus x plus radical 2. Now the 2 cancels with the 2 because it's the plus and minus. So we have limit as x approaches 0, negative x over 2x times radical 2 minus x minus radical 2. The x's get cancelled. So we have limit as x approaches 0, negative 1 over 2 times radical 2 minus x minus radical 2. So this is equal to minus 1 over 2 times radical 2 minus 0 minus radical 2. Sorry, that should be a plus. Notice how it was actually a plus because we multiplied the numerator and denominator with an expression that contains a plus between the two radical expressions, and I just by mistake changed it to a minus. So now that's a plus, so that would be negative 1 over radical 2 plus radical 2 is 2 radical 2. 2 radical 2 times 2 is negative 1 over 4 radical 2.